All right, welcome back. Let's get seated, everyone. So welcome to the third industry pitches session. Today we'll have four speakers, and the very first speaker will be Dr. Michael Suppa from Roboception. So let's please give a hand to Michael.
Yeah, thank you so much for the introduction, Wesley. So my name is Michael. I'm the CEO and co-founder of Roboception. Roboception is based in Munich, and we're a spin-off of German Aerospace Center, founded 10 years ago. And I'd like to tell you a little bit about the story, how we started. So one of the things that really drove us at that time is that we have a quote here on these slides. It's about if we were only able to provide the visual capabilities of a 2-year-old child, robots would get quickly a lot better. And this was basically the driving force for us to really bring perception for robots into industrial environments, into production, for use cases in industrial automation, in logistics, and nowadays also lab automation. What is the problem that we are seeing? So coming from DLR, from the research side, the reality in industry is a bit different. So there's really a lot of manipulation tasks, and there's also a lot of things that have been tried out in industry. And what we are seeing is basically that still there's a lot of mechanical fixtures of parts being brought in the exact same location, inflexible production. And this is the easy cases. And the question is, how do we drive forward industrial automation and logistics towards complex tasks where we have like non-arranged pieces and where we can really exploit the potential of robotics to make them smart and make them smart action and have really a flexible production. It's all about basically downtime, space, money in that domain, and of course reliability and the functionality of the system. So what do we have? So of course we have the environment, so we have a lot of lighting conditions, the perspective on the parts. So whenever you talk to a customer tells you, no, there's no sunlight in production, it's all easy, we know everything about where it looks like. When you come on site, it's the complete opposite. The sun is directly in the bin, and you have to deal with the scenarios because that obviously is not something to shield everything, put it in a box. We have a lot of variation in the material. Usually the first information is never correct. So usually they vary from shiny, transparent, translucent, and then you have to deal with a robot that's going in there very fast. So you don't have the flexibility of putting the cameras and the system in the distance you want to put it, but it depends really a lot on the application. It can be far away, can be very close. So that is really the things that we are seeing. And then we are dealing with an area of the application where there's usually non-experts. So there's technical people, but they're not experts in robotics, and they're definitely not experts in vision. And they need to have ways to deal with the system that is only a little bit of parameterization, but they don't really have a lot of skill. So there's testing, implementation, and you need to achieve something like at least 97% availability. That means successful picks. So if you count that over an hour, you know how many successful picks you have to have and how many failures you can make. And the question is, how do we cover all these cases? Usually there's a lot of, let's say, offsets here to put in. And now for the question is how we can do this. So what we are offering a stereo vision for robots, and we have the appropriate software in order how to deal with that for different applications, such as machine tending, picking, placing, and so on. And we're trying to diversify on the software side, not on the hardware side, to make it also like cost efficient, not to come up with a new sensor anytime you have to do a new application. We are also using AI nowadays, but potentially not in the end-to-end way. But what helps us a lot is basically the synthetic data that we can use for training. So especially industrial environments, you usually have CAD data or some data available that you can use for synthetic data generation that you can basically use also to train your systems. The benefit of that is you have ground truth because you know where the parts are in the simulation. You don't worry about labeling that someone did, but you don't know. And you have also then the option to simulate the light a little bit, things that you usually cannot gather data of in reality. The main purpose of AI is little parameters because our customers don't know to deal with vision parameters. So if they would be expert, they could do it also that way. As they are not, you have to give them just one or two. And the rest is basically the benefit of the AI that we are basically reducing the amount of parameters that we work with. What if we don't have the CAD model? Of course, that's also the case here, the classical industrial case. So you get a CAD model of a motor, and then when you see it in production, it has all the cables on it already. So the question is, how do you do the detection if you only have the CAD model? So basically what you do is you generate the model yourself, and then you apply the same technology later on, basically do some training on synthetic data based on a scanned model. That's also a very easy way. We're doing this also in a European project here. If you're interested in that, you can check on the deliverable that's just mentioned down there. This shows you just a quick video how such a training data set for such a classical industrial part. So this is actually from the seat belt. This has to come basically from a bin. It has to be fed in a machine. And here basically just the scenario that we used as a wide variety of training data in order to address that situation. How does it look like in production in the end? So this is an example how such a machine then actually works. So you have a robot on a rail, you have the cameras that you can see on the rail, and by using 3D vision with the machine learning components, we were able to basically reduce the cycle time a lot from 25 seconds to 12. And what you have to compute there as well, the cycle time includes also the missed cycles, and this is why you can bring it really good together as the machine is just running. So the effective cycle time is sometimes doesn't even a problem, so you must make sure that the machine never stops. So this is basically the way it's done here. Of course, there's a headlight, and there's a lot of unstructured environment, and what we did here is basically from black parts to metal parts to plastic parts, everything in the same setting of the camera, so to say. Yeah, what are the requirements that we have to fulfill? High accuracy in terms of millimeters, high repeatability. We deal with the synthetic data. We never use end-to-end learning. We basically use still a vision pipeline that has components. So a classical refinement still makes a lot of sense. Training time short, 8 hours, not more, because this has to be there next day. And you have to have detection times of 1 second or less, and no basically 3D vision experts on the site. Our solution, basically, we have a smart sensor hardware and software with that. We reduce the cycle times by doing so, down times, and we save space because we can directly pick from the bin, for example, instead of long feeder systems and so on. This ends my presentation. Yeah, you can talk to me if you have any questions in the breaks. And yeah, looking forward to talking to many of you about our solution. Thank you so much.
Thanks very much, Miguel. Any questions from the audience? A quick one. I see one hand over there.
What is one thing you're currently working on?
Yeah, so currently we are expanding the portfolio to also cover unseen objects, so basically something that's considered unknown, because we still see that there are also, especially in the logistics space, there's no CAD models available. That's one. And second is improve the training and to make it faster and adaptable also by the customer. So basically reduce the space so that we have on-site modification availability without retraining. That's what we're currently working on. Thank you. Good question.
Thank you very much. Let's thank the speaker again.
Thank you.